data management in a microservices world. I'm here today to hopefully give you a little bit of a joy and fun episode of some of the latest trends that we're seeing in IT. My name is Gerald Venzl. I'm a distinguished product manager with Oracle in the Oracle database group, funnily enough, hence why I kind of have my data management hat on. In my previous life, however, I actually used to be a Java developer and jumped into performance engineering after that, after I found out that the code that my colleagues and frankly also me wrote was not that optimal to run on big servers, and moved on afterwards into the enterprise architect role, where I got the opportunity in New York City and also in the UK and London to see some of the biggest backend systems that we have predominantly in the telco and financial services world. And that gave me quite a good overview of what companies are actually building that frankly run our everyday business as we know it, or our everyday life as we know it. If you want to follow me on Twitter, I'm fairly easily to find on the web altogether. I have a very unique last name, so it should be easy to find me. If you want to read on my blog, you can find me there as well on Gerald on IT. But let me jump into microservices, right? It's like super great architecture that actually we talk about since years now. And just to recap before we dive into, right, microservices originally brought to us by Martin Fowler and James Lewis. Mostly actually James Lewis. Martin Fowler offered to co-host it on the blog for visibility already back in 2014, 6 years ago. They basically came up with a pattern where we say, well, maybe this thinking of what we back then would have called the typical J2E environment or application server, maybe that's something that's actually not so great going forward. Maybe we have too much dependencies on the different teams. So while it's great to kind of put multiple services, which is what we see here on the left, what we used to call application servers, now it's called monoliths, putting into a big server and then scale them up by having a cluster of the server. That's actually not so great because it causes dependencies amongst each other service and each other teams. So if somebody wants to upgrade the application server version or even Java version, they have to make sure that everybody else is fine to it. So perhaps it would be actually a better approach to, encapsulate each service into its own container or into its own realm, and actually spin up multiple instances when we want to scale that. And I mentioned the word container because sometimes people think that microservices have to be spun up in Docker containers, but actually Docker came a couple of years later. So when 2014, when we had that Linux containers, and Docker was actually in the very, very infancy and not widely used yet. So while they go well with each other, you don't necessarily have to spin up your microservices in Docker containers as per this architecture pattern. But as said, they go well together. Now, I'm pretty sure that actually most of you probably are aware of this, right? It's kind of like a little bit back to the basics and see what people said back then, especially as over the years, people have talked a lot about microservices and what they are or what they are not are. I can recommend to read also this paper of Martin Fowler. One other aspect that they said in there is actually it's really, really important to make microservices successful is to have cross-functional teams. So basically service boundaries reinforced by team boundaries. And what that means in a nutshell is like you no longer have like a team of developers and over there you have a team of admins and over there you have a team of DBAs perhaps, but you actually form the team around a service and you have developers, admins, DBAs, etc. in this one cross-functional team that look after the service. I find that quite funny because most of the companies out there still haven't restructured their teams in that way, especially the bigger ones. And the kind of Martin and James were quite adamant about that if you are not realigning your teams to serve to this boundary of your microservice, it gets really hard to actually keep this microservice under control to keep it running. And so a lot of companies I've already seen this struggle with exactly that. They kind of went down the microservices path and are now struggling to kind of align their teams according with them. And then let's get it onto data management here. Another thing that they said is like here again on the left-hand side, this architecture pattern is like one application server, different services, and one gigantic database behind that server. I would actually call this bullshit. I've very rarely seen a company that would dump everything into one big database and not have different applications talk to different database instances. But fair enough, we can still see from an architectural pattern how this would align itself. And on microservices, the pattern says that each microservice should have its own database as well, right? So just like we decouple ourselves from the application server, from different applications and their version requirements, library requirements, we of course want to keep this decoupling or encapsulation also with the database tier. We don't want to rely on different applications because they want to patch the database now, upgrade it or something, or even dictate which database we should use. One interesting aspect right there on this picture that we very rarely talk about, and in general with microservices, we very rarely talk about, is the whole data management tier behind it. We kind of just go like, yeah, get your own database and off you go. But there is not always a need for a separate database. We see here on the right-hand side that multiple instances may actually share the same database rather than duplicating the data. And of course, a lot of things have changed also in the last couple of years with technologies that came out there and new things that we have learned of what we can do and also perhaps what we should not do. So hopefully, this was 4-minute intro. This makes all sense, right? So we now go into second gear and it gets a little bit more interesting. But I had to set the ground rules. Because when we then took this microservices architecture, we went off and built something like this. Yeah, so these are on the left-hand side the microservice architecture from Netflix, on the right-hand side from Twitter. They look beautiful, right? It's just like a piece of art, pretty much. You could call this the Death Star architecture, or some people do call this the Death Star architecture. And why? Well, because it looks a little bit like a Death Star, right? So if we look into what we've done with like, yeah, let's just encapsulate our microservice, our tiny service, our application, and then let's just talk over REST, it kind of becomes quite a little bit convoluted, right? Even Uber, when we look at their microservices graph, this is just from last year, so much more recent. It's actually not that nicely self-encapsulated, distributed as you may think, right? It's like this fantasy of like, oh, I will not be dependent on anything else, or it's just all very even balanced. Doesn't really exist. You see here very clearly that there's some services, and you saw also before, that are quite central to other services. And of course, what's kind of not obvious in this picture is like each of those lines between the services are essentially network calls, REST calls that to communicate. And they are stateless and they are over the network using HTTP. So there is some latency requirements that we have to consider. But even much more, what's much more painful is to actually figure out who is talking to whom. That can become really difficult, and that's exactly why people come up with graphs like this, so that they have some chance of figuring out, hey, do we actually still need this service? What is it doing? Why is it there, etc., etc. Funnily enough, we kind of like in IT, as we are developers or technologists, we like to create things, right? We like to think big, we like to come up with new ways. Sometimes our new ways are actually just reinventing the wheel from 40 years ago, but we don't necessarily know that because we haven't been around there, and actually who cares what happened 40 years ago. And so it's like we kind of go into this pattern that like complexity is good, or this is good, right? This is what we want. It's like there's actually this guy out there, I have to call him out. This is something that popped up on my Twitter stream. Monzo is like a fintech company in the UK, and they were really happy to showcase that their fintech application is now using 1,500 microservices, and this is really cool. And you have kind of asked him back then, it's like, well, what's so cool on 1,500 microservices? What the heck are you doing? And he was like, well, it's like most of these services are kind of what we would more like call modules or classes of the application. They basically all, most of them need to be spun up together anyway for the application to work. And I go like, okay, so you kind of went over the board and went to some anti-pattern known as nano service. You've kind of like really not decoupled or encapsulated your business boundary at all. You've just created much more headache for yourself. But he was still very proud that he thought that it was really good to show that a startup, is running on 1,500 microservices, because Uber is also running on 1,500 microservices. So it must be a really good thing, right? And yeah, perhaps not, right? It was like, I'm more in this boat of like, why on earth would you ever want to do this? Right? It's like, why did we get to a stage where we think just because some Silicon Valley unicorn is doing something, that means it's really good for us? Why do we think that more complexity is better for us? It's like, in the end, we all in IT to provide some value to the business that employs us, or provide some value via the technology that we're building. And the underlying complexity is actually usually the stuff that bites you a couple of years later when you want to change something, or when you move on to the next thing and you go like, oh, gee, yeah, this doesn't quite work. We have to kind of rewrite the whole thing in something else. And so we kind of waste more time rewriting our applications in something new now, whether it's a new framework, a new architecture paradigm, a new whatever, than actually focusing on providing business value, providing, what the application should actually be doing, and why we are building this application to begin with. So, like, important here to note is, like, just because you think you are not Netflix, Google, or Facebook, right? I mean, it sounds all fancy and cool, but it's like none of those three companies, for example, had anything to do what this Monzo company was doing, right? It's like they really didn't have the need for this massive web scale that these three guys are just have the necessity to, and therefore the necessity caused their architectural choices, which makes perfect sense. Now, let's move on a little bit to the aspect of polyglot persistence, or the data management aspect, right? So it's like polyglot persistence is actually also something that came from Martin Fowler, funnily enough. And that was already there before microservices. There's a paper from 2012 where he so funnily says now that, the future is no longer NoSQL databases, but it's polyglot persistence. NoSQL database was also a term actually coined by Martin Fowler and a couple of other people in 2009 in San Francisco, when they got together for a meeting, and they kind of said, well, sometimes we just don't need a database. Sometimes we just want to quickly store our objects in a cache, in a memory area, and whatever, something where we can just park our Java objects and retrieve them afterwards. That's kind of how they got to NoSQL. They said, like, we don't always need SQL databases. Sometimes we just want a NoSQL database. But he corrected himself just 3 years later, where he said, actually, the future is not NoSQL databases, it's polyglot persistence. Now, polyglot persistence, when we dive into that one, is essentially saying, well, pick the right database for the right job. There's many database technologies out there. It's like, why would you set on one database technology? Why would you set on one data model that the database supports? Why don't you just pick the right database for the right job? And it kind of, although again, this is like 2 years before microservices emerged, so this doesn't really have microservices in the picture yet, but it kind of is sort of aligning itself very, very nicely to microservices. You can see already in this picture here, we have this speculative retails web application. I think he kind of gives Amazon a fancy name, right? It's like Amazon or any other of those retailers, online retailers that we go to. Like, the user, what we see is like one web page, right? But of course, that's not just one static HTML mess behind the scenes. There's many different aspects of the web page, right? We have user sessions to log in. We have shopping carts we put our products in. We have product catalogs where we browse products. They come with recommendations and so forth. And then there's stuff behind the scenes for us to actually make sure that our recommendations get better, that users keep buying products from the website, right? And here he said, well, it's like, as you have these different needs, right, you may just use different databases, right? So it's like, as we see here, user sessions, HTTP sessions. Perhaps let's just use Redis for that. We need rapid access for reads and writes. For financial data, of course, still relational databases are really good for that. Reporting underneath the same thing, right, for those use cases. Shopping carts could go into Riak, which is ironic these days because Riak is no longer really around. And then, recommendations go in the graph database, Neo4j, product catalog, and MongoDB, and so forth, right? It kind of all makes sense, right? It's like on an architectural diagram, it all makes sense, sure. It's like we isolate the shopping cart. You can almost see how those green boxes there are basically microservices behind that application, although this thing has emerged before the microservices paper. So it all makes very much sense. And, we took this approach and we went from our usual databases that we had in the corporation, right? Usually one of those three, and went on and added more databases of different types because we wanted to manage different data, analyze data differently, right? And we kind of just like in the microservices fashion, it's like every microservice can have its own database. So while we can choose our own programming language frameworks, well, heck, let's choose our own database as well. I've never really tried any of these databases anyway. They look really good in our CV, and we kind of went off and, basically, yeah, got one of everything, right? So it's like, again, we kind of found that it's really, really smart for us to just use some database or some technology for our microservice that does one thing really good and like forget about everything else. And that's kind of course, in the grand picture, kind of running all those different technologies and a lot of them actually doing similar things these days. It's kind of just added complexity for very little added value. And, it's like the funny part about NoSQL databases, there is about 350 databases out there currently on the DB Engines.com ranking. Now, I say about 350 databases. There are so many databases out there on dbengines.com that even they gave up counting them, funnily enough. When you look at the ranking and you scroll down, I don't know why, but they all basically stop at 341. They were like, that's enough. We don't need more databases, right? It's like there can possibly not be that many different ways to store some bytes on disk that we need different databases for it. And, kind of, again, what are we doing here, right? It's like, just because we can doesn't mean we should, right? It's like, yeah, of course, there's many different technologies out there. There's many more technologies out there than, we had 20 years ago. The choices are infinite, not only for databases, but for frameworks and for languages and for everything, right? But that doesn't necessarily mean we should just pick something random from the web that we kind of wasted, just like 3 seconds to read the first half paragraph from Wikipedia and decided this is a really smart way of doing things. We kind of have gotten from the, let's first worry about what our requirements are for the application and how we solve this, to like, let's just download some crap from the internet and see whether, we can cobble it together and see what sticks, right? And, perhaps that's something we should change a little bit going forward. Now, one of the interesting aspects when it comes to databases, what I've seen is like, we actually ignore the processing part of it often. So we kind of go like, oh, we want to do JSON documents, so therefore we need a document database. Or we want to do graph, so therefore we need a graph database. But just like the data type and how you store the data is kind of only half the question. It's more interesting is actually the question, why do you store that data, right? Well, what are you going to do with it afterwards? If you're not going to do anything afterwards, you may as well just dump it in a file or not store it all together, right? It's like the processing, what we want to do afterwards, that's interesting. And that's something that we sometimes forget. And just when you align this with the data aspect, you come to what you actually perhaps want to use, right? And so when Martin Fowler actually did this in this page before, he kind of was like, we use Redis because we want fast read and writes, right? He kind of pointed it out, or we do reporting in a relational database because SQL is really, really good. So we should not only worry about this aspect of like what data model or data type we want to store, but also kind of what requirements that we have on top, right? And some of the requirements are pretty much always, in this kind of boat. You want to have lots of writes, right? You need fast writes or you need fast reads, right? Do you have lots of them or not? Do you need data to be consistent? Do you need data to be durable? The two things actually mean different things, right? The durability means like, just do you want to make sure that the data really made it on disk? While consistency means like, you want to make sure that you have the latest and greatest, and you're looking at the right record. And then of course the analytical capability, right? It's like, do you want to do analytics on top of it? Do you want to do graph processing on top of it, spatial processing, and so forth? And just by thinking a little bit further of like, why are we actually storing the data? What do we want to do with it? And I know that often for us, it's also kind of like, we don't really care because we have a transactional microservice. We just process orders and store it, and it's kind of somebody else who has to figure out how much money we made at the end of the month. We're still kind of one big team in the companies we're working for, right? So it's like, there is no good reason for storing the data, then don't store the data. And if there is a good reason for storing the data, just think a little bit further ahead of like, what will happen after we store the data, and how can we make that person's life or that service's life easier as well. And yeah, so the one other aspect we have to talk about here is that there's actually two approaches to polyglot persistence. That's also something that's very rarely talked about. What we saw with Martin Fowler is what we will call a single model approach. Basically, you have a database that can support one data type and one data type only, right? So it's like we have a relational database, and the relational database can support tables and SQL. But if you want to do key value, you pick, you know, a database that does key value, but it only does key value and so forth, right? So you pick the right tool for the right job, and you have picked the multiple databases and database technologies that people have to learn and understand and eventually maintain. Versus another approach, which is this multimodal database approach, where the approach basically where we say, well, you know, there's a database, it's really good at putting stuff on disk and reading stuff from disk, but actually what that stuff is not baked down onto the bytes that we're putting down. So just because you have a relational database doesn't actually mean that that database can only do rows and columns and nothing else. Or just because you have a graph database does not necessarily mean that it can only do graphs and nothing else. And it's kind of like interesting when we look at this whole space a bit, because you know, this is kind of where I come back to the anecdote of like 40 years ago and history repeating itself. Like when we look a little bit of where we came from the data management space, which is granted probably way before any of us were born, but I had the luxury to ask some of my colleagues that have been around there. It's like we approached from the day and age of the 60s, 70s of something called ISAM, which was, funnily enough, a hierarchical data model structure. It's short for indexed sequential access method. It was invented by IBM for NASA, actually, for the Apollo missions. NASA needed to have the capabilities of tracking all the components that's used, all the tiny bits and pieces from, you know, the bolts to other stuff to build the Saturn rocket. They wanted to manage that, and IBM came up with like, hey, look, cool, we give you this ISAM thing, right? You have a Saturn rocket, and then, you know, you have this hierarchical structure, you know exactly which components you need where and how many. And that was really cool, but it was actually really painful, because if you ever needed to change the structure, or if you ever wanted to amend it, or if you ever just wanted to query parts of the structure, it became really, really, really cumbersome because it had this hierarchical structure. And that is when in the 80s, you know, we got the relational model. The relational model kind of fought exactly this complexity. It's like rather hierarchical. That's really good for one use case, but screws pretty much everybody else over on other use cases. Let's use a model where we put a little bit more thought about how we store this data and how we decouple that data and have relationships between them. And then if you have other use cases, you can actually address them easier. I think actually what also helped the relational databases a lot is not so much the tables and columns. That was an interesting format or paper that Cod wrote. But another aspect that made it really easy was SQL on top. And for a lot of people don't know that actually relational databases came like 4 years before SQL came. So it didn't come together, but they came both in the early 70s and mid 70s. And SQL was this one interesting aspect that, again, we're using today often, where it's like, oh, we just have one API that's universal to everything. We just call it by this one API called SQL. You know, nowadays we kind of do like, oh, we're calling it one API called REST. So kind of, we know those benefits, why we're using REST and so forth. And, you know, similar concepts were applied back then to SQL. And that just made it really easy for anything to interact. You didn't have to write your COBOL code to kind of get data out of it or something. No, you could write a simple client applications or anything that just issues this API call, in this case, SQL. In the 90s, then something interesting happened. And this is kind of where, say, so my theory is either the people that were there in the 60s, 70s retired or died off, and new folks came in, or, you know, the folks that were there were kind of promoted somewhere into management that they were so far removed. So in the 90s, something interesting happened, right? So in the 90s, the whole concept was like, you know, object-oriented programming became big, was very trendy. We still use it today. Great method of how we structure our code and so forth. And the thinking was very simple, right? It was like, well, gee, you know, if we already deal with objects in the application, wouldn't it be really cool if we just deal with objects in the data layer as well, right? So we don't have to kind of go with this table column crap and whatever. We just put our objects in and get our objects back, and it's fantastic, right? And funnily enough, so it kind of added to the complexity, because number one, relational databases, as we know, never kind of disappeared. So we had to integrate with those systems. And now we had to deal with these objects. And guess what the big problem was with objects? Well, the object may make really sense to your application that you're dealing with it, but the guy over there that wants to reuse the data, that has no clue about your application and the object structure, now has to learn all of that, right? And if it doesn't fit his need, then they have to basically take your objects, convert the data, and do all sorts of crap and getting their objects that they need. not a funny aspect happened, which is like the relational databases or the database engines behind it, I should say, showcased the first time there that they actually can deal more with tables and columns. And basically object support has been added in every major database back then in the mid 90s, and it's still even there, for example, for Oracle database. The same trick kind of changed, or the same thing happened again, right? History repeated itself in the mid to early 2000s. Everybody was super excited about XML. Same thinking. It's like, hey, if we already deal with XML and the application, can we not just dump it into the database as well? And this time we actually do it right. This time we also give you a query language on top, XPath. Well, guess what happened? XML was just added to those relational databases as well, or to those multimodal databases as well. And you kind of see those icons up there as well, like the predominant databases back then on day and age for that data model. And kind of, if you've never heard of them, that's okay. It basically means they have failed miserably, right? They were basically a one-day show and gone again. And the same thing is repeating itself now with JSON, or has been repeated itself with JSON. And similar thing we've already actually seen with the trend. That JSON has been added to pretty much any relational database that you can think of. Now, why can we do this? So why is this interesting, and how to bring this back to data management? Well, because the relational model always has been a logical one, right? It's like the way how we structure rows and columns in the database, in our application, is completely different from what we actually store in disk. In disk databases don't store rows and columns. They actually store blocks, and they store blocks that are, because the disks that we have is block storage, right? You write blocks on disks, on sectors, and so they store those blocks on it, right? And then within those blocks, we can have a logical data format, and one of that could be rows and columns, right? So like for Oracle database, for example, it looks like this. Our block size is usually 8K. It's usually a multiplier of the disk blocks that you put down on disk, which is either 512 bytes or 1K or something. And within there, we put something that we call, the row pieces, right? And it's like, so what's written on disk doesn't look like rows and columns at all. So if we want to just not put a row down there, but actually something like a JSON or graph, we could do this as well, right? It's like just the block is very opaque to this. Now, what's interesting about Polyglot persistence trends is like that there will always be single model applications and architectures, and of course also databases. And certainly when you're kind of on something new, this is kind of where you would see the single model database first. So that's like when people were like, wow, we're now dealing with JSON and REST APIs. Now we're dealing with JSON in our applications. Wouldn't it be really cool to just store JSON in database as well? It has happened twice already before, right? Yeah, okay, makes sense. And then of course somebody goes off and builds a JSON database, and all they kind of first do is, as they start, is like, okay, we can store JSON. Funnily enough, though, business applications or business logic, like the broader stuff of just storing and retrieving JSON, naturally converge into multimodal architectures, right? So on the one hand, today's edge applications are tomorrow's mainstream applications. And again, JSON is a very good proof point of that. 2013, it was like, oh, wow, JSON database, etc. Today is like, JSON, what's next, right? It's like, well, YAML perhaps, but we want to stay away from that one if we can. But it's like, it's mainstream now, right? It's like nobody cares about JSON anymore. It's like, yeah, everybody knows it. We just deal with it, fine. JSON is not even new. It's there since 2001. But also, the efficiencies of the multimodal architectures override the advantages of special purpose ones in broader systems, right? It's like, if you have a database that can deal with JSON and with relational and with graph, that's kind of neat, right? Because now you can just tell all the applications to use the same frameworks, the same drivers of this one database technology, the people behind it that have to maintain only one database technology, and so forth. So it's kind of like, as you go broader, it kind of makes perhaps more sense to not have many tiny, special purpose different technologies, but have a few, well, they can deal with many different, a couple of different things. But of course, there will always be single polyglot architectures, right? There will always be new edge applications. Of course, there will always be new ways, or at least we think new ways of how we want to deal with something, right? But what's interesting is like, just because if you want to do JSON or graph today, for example, you don't have to have a MongoDB, you don't have to have a Neo4j. You could quite happily do all of this in an Oracle database today, right? It's like one or many different instances of an Oracle database. And, I put Oracle on there because, of course, that's where my salary comes from. But the truth is, pretty much any relational database can do that today, right? Whether it's a Postgres, a MySQL, a SQL Server. You basically, if you just want to store and retrieve JSON, there's very little need for you to go for some specific JSON document store. Again, it comes more interesting when you think of how you want to process the data, right? That's where the differentiation is actually, not so much the storage of it. And truth being told, right, there is no right or wrong, or the famous motto in IT altogether, it depends, right? So like it's a trade-off that you take, right? And it basically depends on your workload characteristics, right? Multimodal Polyglot is good for consolidation and standardization. Single model Polyglot is good for specialization, right? And that's really it. So you have to just think a little bit about what you need. But let's go on, because you probably go like, okay, what is this nonsense by then, right? Multimodal databases, blah blah blah. It's like, does anybody ever use this? Well, I'll tell you one thing. It's really funny to watch the NoSQL space, because they kind of have realized it as well, and mostly from a business standpoint, right? Those database companies have quickly realized, yeah, it's really good to be a specialized database for specialized use case, but you can make only so much money if the market is this big and you only have this speciality there, right? So it's like, how do we make more money once we suck all of that up? How do we expand, right? So it's like, ta-da. Well, NoSQL databases actually also moved to multimodal. They saw the same reason, or the same need for that, right? So it's like, Cassandra had a nice white paper out there, the multimodal data management platform, fantastic, right? Redis with modules is now a multimodal database, can do more than just key values, right? MarkLogic, the original XML database, as a matter of fact, that is not a single database for all your data. They kind of have multimodal down here in the paper, right? MongoDB with 3.4, now multimodal done right, ArangoDB, and of course, the latest and greatest example, Cosmos DB, the globally distributed multimodal database service for any scale, right? So it's like we have naturally moved on to multimodal. So it's like not something that only the relational players kind of go like, oh, we are still relevant. But no, it just makes sense. It's like nobody ever said we put columns and rows down on disk. Nobody ever said we put JSON down on disk. We put bytes down on disk, and everything else is just an abstraction layer. So now let's go a little bit into the hidden pains of the stuff that we kind of basically never really want to talk about when we talk about microservices, right? It's like, this all looks well and good. We're coming back to Martin Fowler's little graphic here. Looks all beautiful, just like microservices look all beautiful, right? But just like we saw the graph before with microservices, this is also not that easy, right? It's like data essentially needs to be passed on, needs to flow, right? If somebody comes in and checks out to a shopping cart, that information has to go to the financial system essentially, right? To build that customer, we actually need to know who the customer is, right? So there's some data that needs to be exchanged, usually via REST calls, right? And then, of course, we want to put in recommendations to our shopping cart. That means we have to kind of already get from the product catalog what other products we have. We kind of have to look into the, activity logs and analytics and so forth of what users actually buying together, what do you want to do, right? So it's like the whole picture looks really nice here and very self-isolated and encapsulated when we talk of it from a transactional standpoint, but actually there's still a big pile of mess behind it that, or data movement behind it, or data analysis behind it to sort this all out, right? And then, this goes on and on, right? So financial data needs to go into reporting, we need to go into analytics, etc. And a lot of errors at the end. And of course, then somebody in security usually comes in and says, hey, do you make sure that there's the credit card information, the reporting logs or whatever, right? It's like all your surfaces of attack, of potential attack, could be much bigger. And a lot of times you don't even know how big they are, because you don't even know where the data is stored, because most of the times these days we just duplicate data. So we kind of solved this all in the early 2010s, right? We say, stop, this is completely nonsense, this makes no sense, let's come up with something brand new, revolutionary. And this was this guy. This yellow kind of little guy used to be called Hadoop. It's 2012, Hadoop will, make all databases obsolete, right? And we had this beautiful picture of it just being like, oh, we just store all the data in there and it will magically solve itself. People can just surf from that, right? It was our little unicorn for the data management aspect. And very quickly, though, evolved into this guy, right? Basically a huge pile of mess. It's like garbage in, garbage out is the famous saying, right? It's like, yeah, made it really easy to put data in. That still doesn't mean it made it really easy for the guys on the other end to figure out what the data was, right? And we quickly ended up in kind of this mess, right? The elephant started to fight back. And when you look around at where Hadoop is now, just eight years later, from like it will, revolutionize the data management space, databases will all be gone. Well, it's still there, but not that prominent, right? But we said, Hadoop was actually a mistake, or maybe it wasn't a mistake, but it kind of didn't solve everything, right? Stop, we find out something else, right? And that's this thing, right? It's like we just use event sourcing. This is way cooler. You know, our applications just store the data in their databases and then you dump everything in Kafka. And behind me, I don't give a shit really. You know, people can just start figuring out the data from over there. And it's even better than Hadoop because every modification that we do, we just put every modification in. So they can even go back in time and figure out what the state of an object or a state of a piece of record actually was 3 weeks ago. Although most of the times they probably just care about, hey, what's your customer name? Please give me your customer. Or they can figure it out all in Kafka, that is, right? And that kind of reminds me a little bit of this, right? It's like, okay, there's a lot of data coming there to this guy over there, and you know, being on the end of this green light, and whoever is on the end of this green light, I think, is kind of in a little bit of a trouble there. And we moved on and said, you know, event sourcing goes really well with CQRS, right? It's like rather than just putting the random information in there, you know, we should really have this command query separation, responsibility separation, and perhaps we just, you know, store commands or use commands to store the data into Kafka, right, rather than something else. And that kind of reminds me a little bit of this guy, right? It's like, I mean, how can you just make it even more complex for the poor guy that just wants to figure out who a customer is, right? It's just plain evil, really. So it's like, again, why on earth would you want to do this? And actually, who on the earth actually told you to do so, right? It's like, when you actually read the CQRS inception paper from Greg, right, he kind of makes it very clear that CQRS is, number one, not an architecture, right? Number two, it's just a pattern where you basically create two objects out of it. It's CQRS is not eventual consistency, it's not eventing, it's not messaging, it's not having separate models for reading and writing, nor is it using event sourcing, right? None of this. It's like, it's basically just with CQRS, you will have two objects in your code where there was previously one, right? So it's like, okay, interesting. So why are we now saying CQRS and event sourcing is so great? By the way, this blog, 2010, right? 10 years out there, amazing, right? But anyway, right, it's like people say it's really cool, we should do this. And Kafka is like now this new thing that will just take on all the databases, except when you actually read on the Confluent blog and ask, you know, that one of the founders or creators of Kafka, you know, he says, yeah, I mean, people often ask me, well, will Kafka become the universal database, right, obsoleting everything else? And the answer is probably not, for two reasons. The one reason that is really interesting, he's like, databases are mostly for querying, right? And Kafka doesn't really benefit from trying to do any kind of random access and analysis on top of a log. And that's exactly right. Databases are mostly there for querying, right? The right aspect for database is it's actually the boring part of it, right? It's like the SQL and analytics and constructing pieces of data that sits in different tables and rows. That's what databases are really good for, right? And Kafka was never built for that. And, you know, it will probably just be like Hadoop, or perhaps a bit better than Hadoop. We don't know yet, but it will most likely not replace all the databases because it was built for a different purpose, right? And it's funny, the information is out there, but people kind of never really tell you this stuff, right? They kind of go like, just use my technology and everything's fantastic. And it will solve all your issues until 3 years later, I have a new technology or something more interesting. Now, funnily enough, this is the paper from Claude going back to 1970, 71. And, you know, he kind of nailed it, why he came up with the relational model from, I love this, that he says here, data banks, right? So we talked about data banks back then rather than databases. It kind of has it in the very first sentence, why he came up with this. So the future users of large databases must be protected from having to know the data is organized in the machine, right? So it's like, if I come in and I look at your data, I should not have to understand your data structure. I should not have to understand your JSON structure. I should not have to understand your object. Should not have to understand your ISAM. It's like history is repeating itself. Hierarchical data structures aren't bad, but they're really shit for reusability. If somebody's coming down the line, they now have to understand why you structured the way you structured it, right? They're also sometimes really, really bad if you want to just query parts of that information and parts of some other structure that's in another hierarchical data structure. And that's literally why he came up with the relational model. It just, you know, you take all those pieces, you put it into different tables. And then if you just want to see all the customers that are out there, you can do so. And if somebody else wants to see all the addresses that we have on file, they can do so without even having to worry about the customers and credit card information and what have you, right? They're all separate tables with relationships between them. And yeah, it goes on there a little bit more, you know, basically the same thing again, right? Application programs should be unaffected when the internal representation of data is changing. If you think that your object should change now because the application has changed, well, guess what? If 5 different people down there just learned how your object looks like, you changing it, you're breaking all their apps, we kind of end up again in the same boat that we were before, right? And now, of course, you could say, well, with microservices, of course, we abstract this in a microservice and so forth, right? And we do this all over REST. But again, we have different data processing needs, right? And it's like, and unless your microservice wants to be the transactional service, as well as now the analytics service, and unless you want to kind of get into the mess of like, well, you know what, now my checkout service and my financial reporting service have to hash the data together that we actually figure out which products we sold most, it gets complicated, right? It's not as simple as we put it on PowerPoint as we talked about it. It gets complicated. So yeah, you know, like one of the reasons why this whole schema on read, why this situation we're in is like, it's basically, you know, much harder to understand the structure from other domains after the fact, right? It's like, again, it's like me having to figure out what this object structure from 3 years looked like and why it looks the way it is harder than from actually putting in some more thought on the schema on write aspect where, you know, everything is defined, okay, the data goes into that. But that's fine. I mean, you know, it's like the schema on read is not a bad thing either. It just brings this inherent data cleansing problem. And that was the big problem that Hadoop had. You know, garbage in, garbage out. And I think that is also one of the big problems that Kafka has. And it has nothing to do with these technologies. It has to do with garbage in, garbage out. So just because it sounds cool doesn't mean if it's a use case. Now, I want to leave you with one thing, because I think for IT, it's time to move on a little bit to think about all this in kind of all these low-level areas and kind of in this, you know, religious attempt of like right and wrong, right? It's like, the microservices paper is there since 2014. It's 6 years old. In IT terms, it's pretty old, right? I mean, it got popular a little bit later. And it's fine, we do microservices now, right? And it's fine, we also actually see companies moving back to monoliths because they go like, you know what, microservices don't fit everything, and that's okay. And the paper never said, you know, rewrite every app into a microservice. Sometimes a monolith is just better, and that's okay. It's just an architecture pattern, right? But for the data management aspect, perhaps we should not take this also too literal of like every microservice has to have its own database, right? Perhaps we should not even think of databases in such a sense anymore, right? Perhaps we should think more a little bit of like data as a service, and especially in the day and age that we are nowadays, right? Perhaps it's just okay that I have a microservice and it stores and retrieves data from somewhere else. And I actually don't even care what's behind there, right? It's like whether it is a Mongo, an Oracle, or MySQL. Why would I care? I'm writing my microservice. I want my data, right? It's like, that's it. And perhaps it's then okay that, you know, this same data as a service serves other applications as well in other means, right? It's like, perhaps it's fine that I don't have to deal with like the mashing between the reporting and the shopping cart and what have you. Perhaps it's just fine to say, look, this information sits in this data as a service, and we query it from that data as a service, right? And it's like, and so to some extent, that's sort of what we're doing with Kafka right now. But again, Kafka is not a replacement for databases. It actually makes the analytics part really, really crap. Even KDB is a fantastic product as well, but it's streaming SQL, right? It's like, you always have this notion of streaming SQL, etc. It's like, it's not a fully analytic SQL 2016, ISO SQL 2016 capabilities that databases, relational databases just have. And, you know, in the day and age of cloud where, you know, stuff sits here and stuff sits there, perhaps this is just the way how we have to think of it, right? As we have microservices, and perhaps we have a microservice for the data or whatever we want to call it, or a data service or whatever. And we don't take this too religious that I have to have this database as part of my microservice, etc. This is something that we think very highly about at Oracle. We actually introduced this free tool on top of our product called Oracle REST Data Services that allows you to just abstract your database as a REST call, or, you know, parts of your database, your tables and so forth as a REST call. We really think this is really powerful. We should no longer have this debate of like, this database is better than this database. We should talk about, why are we storing the data? What do we store it for? How do we process it afterwards? Rather than making this a religious debate about the technology behind it. And with that, I would like to thank you very much, and I'll jump into questions now. We have about a minute time or two, although I think I can probably run a little bit over. So if you want to unmute yourself and ask a question, that's fine. Otherwise, let me go through here and see whether there are any questions. Okay, Frederick is saying that he gets the sense that I don't like microservices. Actually, it's not whether I like or dislike them. I think it's an architectural pattern. And if you tell me microservices are great for everything, then I will tell you you're definitely wrong, because I have not seen a single tool or a framework or what have you in IT that solves all the problems. Otherwise, we would all be out of a job since the 80s. There wouldn't even be jobs. because in the 80s, I think people thought a lot longer and harder about problems that most of us do these days. Of course, current company excluded. Then slides are running. I don't see the slides, browser, etc. Okay, zoom. Has the TPC microservice problem been solved? What are your thoughts of TPC in general and with microservices in particular? So here, putting my database hat on, are you talking about the TPC kind of benchmarking, or are you talking about TPC, the internet protocol? If you could please just clarify and chat quickly now, I will move on in the meantime. What is your take on microservices, which is talking a lot about this conference? Yeah, well, I hope, yeah, it depends exactly. Frederick got it right there, so I think I'll move on here. What's the downside of data as a service is more latency, isn't it? Well, frankly, yes, I mean, it is, right? I mean, the downside of microservices in general is latency, right? It's like going over the network via REST call will be more latency than just calling something in your user space, right? So that's one thing that always kind of I found interesting. But you know, as data as a service, like there's also one thing that goes along with it, right? This is this whole religious debate of like, don't put business logic in your data tier, which is like, and I gave this in yesterday's talk. It's like, well, you know, put business logic wherever it makes sense. Well, it never makes sense to, you know, pull over 3 terabytes of data and then aggregate it in your application, right? Just let the data technology do that for you, whether it's a relational database or something else, right? Why would you, right? So it's like, but yes, indeed. I mean, of course, for analytical requirements and stuff like that, I think the data as a service, you know, you would kind of put this into the data tier and then just call it as a REST call or something and get the answers. For OLTP, yes, you have more latency. So just like you have more latency on top of your microservice having the message come in. If that doesn't work for you, then yeah, fair enough. You know, it's like, again, it's one aspect of it. You can have your database still connect, or you can have your application still connect directly to your database. There's nothing wrong with that either, right? Just don't make it a religious debate of like, I have to use X because I love X on my CV or something like that, right? Just, you know, think a little bit more about the requirements that you have. How does this Oracle REST service pattern decide what DB to use under the hood? So it's actually not two-phase commit, or, well, I don't know whether there was a follow-on or not. Oh, so that was TPC. Thank you. I'll come back to that. So the REST service pattern, essentially, so we ship it out of the box, right? So you can enable just REST on top of an Oracle database today. So, and therefore, you know, basically in your URI pattern, you have basically the schemas in your URI pattern. You can obfuscate them. You don't have to turn on every schema, and you know, you have all this security stuff. But that's basically it, right? And then CRUD operations, simple OLTP kind of CRUD operations, they are just abstracted in the REST equivalents, right? You will have your post, get, put, etc., just like you would have in CRUD. And essentially, what it does as you issue that REST call, it will translate this into SQL, executed SQL, and marshal it back to as a JSON response to you. That's kind of how it works. You can create your own REST services. You can go in there again when we talk about analytics. You can basically put any SQL in there, or any stored procedures, or anything else really that you have that you can do today on the database, and basically say, you know, hide this piece of code behind the REST service, whatever that piece of code is. And then, yeah, so I think the TCP question, two-phase commit. So two-phase commit is an interesting one, because I see right now that a lot of people push sagas for microservices in general. And you know, like sagas are also very, very old. They're from the 80s, and they're basically, I mean, a bit cynical on this one, right? But when you read through the sagas paper from the 80s, it's basically roll your own two-phase commit. So it's like you have to write the logic for acknowledging your transaction. You have to write the logic for rolling back the transaction. And it's kind of funny because the saga pattern appeared before the distributed two-phase commit stuff came out, because people were like, this is stupid to write our own logic for every single service that we're having. So, you know, I think right now there is no good answer to that yet. I mean, you know, sagas might be great for the use case, but, you know, it's a lot more hand coding yourself. And you know, putting transactional system together is kind of, it's a complicated task, right? It's like, that's why we actually want to use things that come with we want to use databases and other stuff that kind of do this for us, because, like, you know, like transactions are fine if you just say store it and whatever. Consistency is the tough part, right? And whether you care about that. Well, actually, did somebody else overwrite this while I was there and so forth. So I don't think there's a good answer just yet. I think, I have seen microservices implementations where they go back to two-phase commit. I've seen microservices implementations where they use an even older pattern that was around in the 70s with IBM, where they basically use a kind of like a transaction coordinator broker kind of system where the microservice sends over a message to another microservice. And while it's doing so, also in parallel, sends off a message to this other thing saying, hey, I sent this request over. And then the other microservice has to talk back to this thing saying, hey, I received this request and finished it. And if that were not the case, then this other thing will talk back to the microservice and say, hey, this thing has never been finished. So, this apparently this system has been, or concept has been around since the 70s, way before my time. So again, I don't think there's a good answer, but this is definitely one of the crux we need to solve. But that's true with any distributed system, even if you were to have a couple of monoliths and they need to exchange data and so forth. But something to think about when we split this out as well, right? That we don't end up in this mess. Thanks for having me. And yeah, see you soon. Thanks. Bye.